I'm going to be doing story problem number 104 on page 216, and this is in section 2.7. And here we're looking at twice the difference of a number and 3 is greater than or equal to the number increased by 5. So here I'm going to let x equal the number, and we're going to take twice the difference. So twice the difference means I'm going to be multiplying 2 times the difference of a number and 3. So we're going to be multiplying 2 times the difference of a number and 3. And that's going to be greater than or equal to the number, which is x, increased, that means by adding 5. And then we're asked to find all solutions. So this is the tough part of the problem. I think the hardest part is the beginning where it says twice the difference of a number and 3. So we have to remember that we're going to be multiplying 2 times this difference. So going ahead and solving, we're going to go ahead and use the distributive property on the left. Then we're going to subtract x from both sides. And we end up with x minus 6 greater than or equal to 5. And then I'm going to add 6 to both sides. And my answer becomes x has got to be greater than or equal to 11. So the number is either 11 or more. The number is either 11 or more. The next problem we're going to do is in 6.1, and that's on page 426, and I'm going to be doing problem number 56. When Kate exercises, she either swims or runs. She wants to spend a minimum of 8 hours a week exercising, and she wants to swim 3 times the amount she runs. What is the minimum amount of time she must spend doing each exercise? So we have swimming and we have running, and she wants to spend a minimum of 8 hours a week exercising. So between the two of these, she wants to spend at least 8 hours. She wants to swim 3 times the amount she runs. So if she runs X amount of time, then she's going to swim 3 times that, so she's going to be swimming 3x. And then it says, what is the minimum amount of time she must spend doing each exercise? So this is how much time spent swimming and time spent running. And she wants this to be at least 8 hours a week. So she wants this to be at least equal to 8 hours or more. So that's going to be your equation. So together, the 3x plus x has to be greater than or equal to 8, which means that 4x would have to be greater than or equal to 8. And dividing both sides by 4, we end up with x is greater than or equal to 2. So that means that she's going to have to spend at least 2 hours running, and 3 times that 2, which equals 6 hours swimming. And I've got that 3 times 2 from up here, where 2 is what I came up with. I put it in there, so that gives her at least 6 hours. The next problem is going to be problem number 64 in the same section. And we're given an equation here. P is equal to 64,800 plus 2880 T. And this means that P is representing the pay per year for a chemical engineer major, and T is representing the years worked after college. So you might want to make yourself a little note here. P equals pay, T equals years after college. And in this particular problem, it says, how many years would a chemical engineer major expect to work to be earning at least $108,000 per year? So at college, so right when they get out of college, how many years after college is it? It's not any years after college. So right when they get out of college, so this is right after college, that's where T is going to be equal to 0. So if I put in a 0 here, P is going to be equal to 64,800 plus 2880 times 0. And 2880 times 0 is 0. So this right side then becomes 64,800. So this would be the starting salary after college. Now they didn't ask us this, I just wanted to give you an idea of what they're talking about. So now they want to know how many years, so with this time, in this particular problem, we're looking for T. And they said, how long would it take for you to earn at least 108,000? So we're going to put in 108,000 for our P, 108,000, and we have this formula, 64,8 plus 2880 T, and it says to be earning at least. So we want to have this be at least, means we want to have be equal to, and at least means that we want this to be more. So either equal to or more. So that's the inequality we need to solve. We're going to subtract 64,8 from both sides, and that's going to be equal to 2,880 T. I still have my less than or equal to sign here. Then I'm going to divide both sides by 2880, and I end up with 15 less than or equal to T. So T has to be bigger or equal to 15 years. So that means that the chemical engineer must work at least 15 years.